talking about what's been learned from a very large collaborative project of scientists, managers, and regulators about how we can adapt to climate while we're trying to restore an ecosystem. And what ecosystem are we trying to restore? San Francisco Bay, but not just all of the bay, actually the Baylands. And what that means is the areas between high tide and low tide, and also what would be between high tide and low tide if there were no levees or other barriers. Basically amounts to what was intertidal in the 1850s. And I'll be getting into why this is important, but basically this is the ecosystem you want to have if you want to be protected from future storms. This is the thing that Gary said most of California doesn't have a lot of. Well, in San Francisco Bay Estuary, we're really lucky we have a lot of it. Doing a ton of work for us, and we're trying to figure out how can we restore it and keep it around for a long time. So what I'm going to actually be talking about is an update to a report that was completed in 1999, and now in 2015 we're updating it. So I'm going to show you the iconic image from that 1999 report. It was an extremely successful report. There's the cover in the upper right. And one of the reasons it was successful is it provided this vision. It said, what did San Francisco Bay used to look like in 1850, and what does it look like now? And I think people were very surprised to see how much tidal marsh we had lost. About 85% of it was gone. And that inspired people to really think about restoration in a whole new way, at a whole new scale. Well, now I can show you the whole picture for our entire estuary, which includes the delta, which is what we are sitting next to today. That's why sea level comes all the way up to Sacramento, as Gary was saying. Where was the big marsh historically? It was here in the Delta. The Delta marsh is actually half again as big as all the marshes of San Francisco Bay and Suisun Bay put together. And it's also been lost to a much greater degree. 98% of the tidal marsh up here is gone. So I make this point, one thing is to realize that we can always learn new things. Even what we thought we knew is kind of surprising sometimes when we actually look at the data. But also to remember that we're one estuary. What different parts of the estuary do is going to affect the other parts, so our decisions matter to other people. And also that the ideas that we've come up with for the Baylands goals that I'll be talking about today, they apply here, they apply probably in the Delta and in other areas of coastlines around the world. So we're hoping that these ideas can be used elsewhere as well. So why do we care about tidal marshes? Tidal marshes are the dominant habitat in the Baylands, but why do we care about the Baylands in general? Because they do a lot of work for us. They provide us a lot of ecosystem services. So what do? They help clean the water. They help provide flood control. In particular, they attenuate waves. They knock down waves during storms and high water events. They're very important for fueling the food web. They support wildlife. We have lots of endangered species in the tidal marshes of San Francisco Bay and elsewhere in California. And we like to recreate in them. We like them. They're pretty. They're part of the beautiful sort of iconic image we have in San Francisco, in the Bay Area of our shoreline, and I think this is what we want our shoreline edge to look like. So getting back to the Baylands goals, there actually was a static habitat acreage goal of 100,000 acres set in that 1999 Habitat Goals report. That's how much tidal marsh we wanted to have in the ecosystem for the Baylands to be healthy. So looking at the left-hand bar, you see that was the historical amount of tidal marsh, 190,000 acres. Well, our goal was more or less half of that. And at the time the 1999 report came out, there was about 40,000 acres of restored and original tidal marsh. And the most recent data point we have is from 2009, and we can see that there's been an increase of about 6,000 acres of restoration that happened since the Baylands goals. That's pretty good, but you might say, well, that's not that thrilling. Well, the thing that's really thrilling that the Baylands goals report helped do in 1999 was foster planning for restoration, acquisition of land and planning of enough restored marsh, there you see in the post-restoration column on the right, that we would get to 72,000 acres of restored tidal marsh, a huge jump toward our goal of 100,000 acres. And that just shows you how long it takes. This was incredibly fast to get that much into purchase and planned in 15 years. It takes a long time to do this. It takes a long time to get through the lawsuits and the permitting and make these restorations happen. So this is why the Baylands goals was so successful. It was this sort of sea change, if you will, in how fast restoration could happen. The largest restoration project went from 350 acres to 15,000 acres, or 2 orders of magnitude. It was written into policy in several key agencies. There was a dramatic increase in funding, and it inspired other goals projects. So this is held up as a model of a successful approach to doing a large collaborative project like this to try to make change in the ecosystem. And I'll talk about some of the lessons that we learned from this and how we're using them this time around in a moment. So why are we doing it again? Why are we iterating this? Well, it's because of climate change. And I'll just set up one aspect of climate change that we looked at, some of the key aspects. There were many other problems, as you can imagine, from climate that we had to tackle. The big one that we looked at was sea level rise. You're familiar with this curve. And I just put it on a longer timeline here so that you can see that that inflection point that happens around 2050, that's where we really start to get into trouble with the Baylands. And the issue is that the marshes have trouble gaining elevation or accreting material fast enough to keep up with the water level. Exacerbated by the fact that we now seem to have a lower sediment supply than we had during the whole history of development of the San Francisco Bay Area. So there's been this step change in sediment supply. We don't think it's going to go back up. It's a complicated story. But if you can imagine that you need sediment for your marsh to accrete rapidly, but now you have less sediment and sea levels rising, you can see that it's a double whammy for the marshes. And what you're looking at here are projections from models of how marshes can keep up or not with sea level rise. So now we're adding the biological process of marsh accretion onto all the models that we've seen of sea level rise today. And what you can see here is we actually find ourselves, unfortunately, in this scenario on the left, which is high sea level rise and low sediment. And you can see as you go from the left-hand bar in 2010 to the right bar in 2100, that the amount of marsh that there is, which is the light green, dark green, and yellow or orange color, see how that shrinks as you go from left to right? We're basically going to lose our marshes over the next 100 years if we continue with business as usual. There's a little bit of low marsh left there, the light green in 2110, but that'll be gone in the decades after that. So that's the problem if we want to retain the ecosystem services that are so great that are coming out of these ecosystems. But here's the interesting thing. There's a lot we can do about it. We can shift ourselves over here to the high sea level rise, high sediment supply scenario. And it's amazing to see the difference in how marshes survive over time in this scenario. You can see that there's a lot of marsh left at the end. In fact, actually increase your amount of marsh for a while in the middle. So this is one of our really big management knobs that we can turn and that we need to turn if we want to retain the ecosystems, and we basically want to protect the shorelines behind them. So now you understand why we did this report. We call it the Baylands and Climate Change, what we can do, because there is a lot we can do. This is a report that was funded largely by the California Coastal Conservancy. They really championed it, kept it going. And it's also a report of the Bay Area Ecosystems Climate Change Consortium, or BACE. So getting back to those lessons learned from the 1999 report, one of the key lessons was that it really needs to be founded in science. If you're going to do this big collaborative effort, you need to synthesize the science, and then you basically have this unified voice coming from the scientists about a mandate of what needs to be done. So that's what we did this time. Our goal was a healthy ecosystem that provides a resilient shore for people and wildlife. So this is an ecosystem that can sustain itself over time. That's what we're trying to get to. We know that's good for wildlife. We also think it's very good for people. And we provide recommendations about what should be done, but also landscape visions for the next 100 years. So not just what should be done, but more about what should be done where. Not every approach is good everywhere, and we think this kind of more localized understanding of what should happen in different landscapes is really important. Another important take-home from the 1999 Baylands Goals report was that working across the interface of science and policy was really important. So the report is written by scientists and it's about science. But our steering committee were the state, federal, and local agencies that are involved in regulating the Baylands, restoring the Baylands, creating and interpreting policy about the Baylands. So it was very important that throughout this 3.5-year process, we've been going back and forth talking to them. We've been trying to understand what are the management questions they have, how do we need to communicate the science so that it can be useful to these agencies. And that's part of what we think made the 1999 report powerful and will also make this one powerful. In addition, we have an outside science review panel of 6 experts that gave us great feedback along the way to improve our work. And then we've got about 200 people who actually helped write this thing. It's really big. You'll see if you ever check it out online. But we do have it synthesized down into shorter things to read if you don't want to get into 1,000 pages. So what are the 3 things I'm going to tell you that we can do? The first one is we need to restore complete systems. What does that mean? It means let's not think about restoring habitats. Let's think about restoring the processes that create and maintain habitats over time into the future. So if we're thinking about the Baylands or tidal marsh, we need to restore the marsh plain, and that's the stuff in the middle, the high marsh, the marsh plain, and the low marsh, the tidal marsh. But also the lower elevation habitats that protect the marsh. So that's things like the mudflat, the oyster reefs, the eelgrass. Sometimes there's a beach out there on the bay side of the marsh. All of those things protect the marsh physically, and then the marsh protects whatever's behind it. And so what's also important is the area between the marsh and the upland. That's where all the creatures have to go when the tide gets high. But then if you think about it, what's behind that transition zone? In the Bay Area, that's a lot of stuff that we care about that's being protected by this ecosystem. So that might be the Oracle buildings that we saw earlier. That might be your sewage treatment plant. It might be the freeway that you drive to work on or your house. So these kind of ecosystems are important for protecting physically what's behind them. If we're going to restore the complete system, it's not just about restoring that space that I showed you here, but it's also about thinking at the larger landscape scale. The Baylands are a wetland system that interfaces between land and the bay, or the sea, depending on where you are. And what that means is we need to restore the land processes from the watershed and the ocean processes, the bay processes. So from the land side, we need the hill slope and alluvial processes that bring sediment into the Baylands, and we also need the fluvial processes that bring fresh water and sediment into the Baylands. If you look at this artist rendering, you can see around that stream coming in at the bottom right, there's a little wetland complex, there's a riparian corridor up the stream. There's a lot of really important ecosystem values there. So that's a lot of the new thinking that's been coming in from the watershed side. That will benefit the Baylands. How do we restore natural stream hydrographs? How do we let groundwater recharge happen in floodplains? All those things that tend to be good for water supply and water quality are also going to be helpful for restoring the system that we need to maintain the Baylands. In addition, we need to think from the bay side or the tidal forces side. We need those tidal forces to make the Baylands the Baylands. We've been much more aware of that and better at doing that in our restoration so far. But what we shouldn't do is take a step backward and start building tidal barriers that prevent those forces from bringing water and sediment into the Baylands to help build them up. So it's interesting to think that from the tidal marsh point of view, you need your storms, you need your high water to push sediment and water up into the Baylands. It actually lets them build up and keep pace with sea level rise. Okay, so getting a little bit more down to brass tacks, this is a real project that SFEI has been doing for the East Bay Discharges Authority. They are thinking about what are we going to do with our wastewater infrastructure because sea level rise has been inundated. So they're really looking at innovative solutions about what to do as they update infrastructure. And that's a huge opportunity for us as we think about restoring the Baylands. So we looked at, okay, well, what are the ways that this water gets to get to the bay around the edge of the Baylands? And on the top left there, you can see it just sort of peter out into wet meadows, or if there was more water, it would peter out into a wetland complex, really important for wildlife. Or if it had a lot of power, it would get all the way through the Baylands, and it would put sediment and fresh water into the Baylands, again, helping them accrete and grow rapidly. Well, now, in the left and right condition there, you can see that they're just levees. That water goes straight out to the bay, no sediment or fresh water getting to the Baylands. Or in the middle condition, it's completely piped, so the connection's gone altogether. So what could we do in the future? We're not saying we should restore to the past, but we can use the past for inspiration about what would be most valuable and functional. So on the left, you can see that we could create low slope levees or horizontal levees with seepage coming from many different areas and create kind of constructed wet meadows. In the middle, you can see that we could create more managed wetland complexes, very important for migratory birds. Or we could actually put the water back into creeks and let them push sediment and fresh water into the Baylands. No levees this time, putting those forces back right into the Baylands where they need to be. Sorry, my mouth is dry. So those natural processes are really important. But we can also maximize our utilization of sort of unnatural processes of sediment and fresh water. In particular, we need to really reuse all of the dredge sediment today. We're not doing that now, which is amazing because we've known that we need to do that for decades. But we need to do it. All of this sediment is very precious for keeping a resilient shoreline. And we even need to think about using excavated sediment from the watershed. So wherever we can get it, clean and appropriate sediment can be reused in the Baylands. Okay, so what's another important idea that we can take out of this? And that is to restore soon. It's really important that we get started on restoration very soon because marshes that are in place before that sea level rise curve gets going faster are much more likely to persist for several decades longer. So we don't want to do that just anywhere. We need to do that in places that have the right sediment supply that will let marshes keep going for several decades. So what I've been talking about so far is how to help baylands grow vertically, but we also could let them move laterally. So they are naturally going to want to move inland or migrate over time as sea level rises. And if we plan ahead, we can let them do that. Maybe it's even cheaper than trying to help them retreat vertically. We can let them move laterally and create a space for them to do that. So if you imagine that this is the current boundary of the baylands, you have a tidal marsh there on the right, a stream coming in from the left, we can predict pretty accurately where those baylands are going to want to be in 20, 50, 100 years. And we can identify this land area and decide what's appropriate to do with it. There's a lot of things you could do with migration space. You could acquire and conserve if it's undeveloped. You could construct an actual transition zone migration space using a horizontal levee approach. Or you could do planned retreat as we've been talking about for a long-term goal where necessary. Okay, so what can we do? Restore complete systems, including the processes, not just habitat restoration anymore. We can restore soon in areas where baylands are likely to persist, and we can plan for the baylands to migrate. So how does this really work? You can actually put these ideas into a management framework that has thresholds and decision points and lead times to get to effective solutions. And this can help local communities plan how to integrate all these pretty complex ideas together. But how are we going to come up with a local vision? We do have one idea coming from the report, which is to define practical science-based shoreline units. So these are units defined by things like sediment supply, wave action, and those units define what type of adaptation is going to be appropriate in any particular area. And then within those boundaries, bringing stakeholders together to create a long-term vision of resilience. And this is where we get back to that lesson learned from the original Baylands goals. Having everybody sit down together to talk through a vision and agree on it and own it and sort of be behind it was very powerful, and we think it can work also for shoreline planning. We need to get together the ecosystem people, the social people, and the economic people and realize, what are the different ideas and constraints we have, and can we agree on a vision that maximizes the cross-sector benefits. So I want to conclude by saying we know we have choices to make. Everyone's been saying that today. We know this is coming for the Bay Area and other parts of California. But I don't think we want to have this everywhere. And so I invite you to come check out a report and think about how can we prioritize natural infrastructure for climate adaptation where it makes sense. And unfortunately, we don't have a website available right now. The report isn't coming out until October. But you can come visit our SFEI website where we're working on other resilient landscape approaches. That's at the bottom of the screen. But also invite one of us from the Baylands goals to come talk to your group. Invite one of the scientists or one of the steering committee members. We want to start these dialogues to figure out if there are these synergistic approaches to shoreline planning. And I'd like to thank our funders, especially the Coastal Conservancy, and all the contributors to the project.